Hello? Can everyone hear me?
We hear you.
Okay, great. Sorry, Mike Giordano, project coordinator for Afri-Set, executive director for Africare. Sorry I couldn't be there in person with you guys. I just wanted to make a really quick comment on the previous question, um, which is the question is, what do you kind of do if you don't have a reference monitor and whether you should put things inside or out? And I think at Afri-Set, our take on this is if you put them together, right? You put all of your sensors together and you compare them to each other. That's good and absolutely necessary, right? To make sure that they're responding in the same ways. The flip side of that is putting
Just
them
gotta type it.
inside is
Type it.
going to probably give you a lower range of responses, both to concentrations and temperatures and humidities and all the other things that change sensor response, right? As compared to when you would put them
Hey
outside.
Mike, maybe you should type the comment in the chat box.
Is it Okay, it just went out. Okay, I'll just put it in the comments. Sorry, thank you.
Yeah, let's take another question from the in-person folks. No? Oh, yeah, Steve. I think Steve has a question.
So this is a philosophical question. Um, some sensors, when the signal is actually below their detection limit, will sit there and vary negative and positive. And I'm always worried that people just throw away the negative and bias everything positive. So I just throw it out as a word of caution that, small negative numbers might just be the natural variation of the sensor bouncing around zero. And if you remove them, you're biasing your average up. Now, large negative numbers is a very different thing. But depending on the sensor, there might be some of that hysteresis, and you would also have to do something to the positive numbers too. But anyway, I just make that comment.
Yeah,
Some sensor manufacturers take care of this, but not all sensor manufacturers take care of this.
yeah, that's an excellent point. That I did make a generalization that if you have a negative value, you should discard it. It was buried in one of my bullet points that kind of just flew by, but there is the possibility of doing slight negative adjustments. In our experience, we typically see this with the gas sensors. When we're at very low levels of ozone, for example, we'll often see the sensor signal drift into negative. And if it's like, not more than negative 5 ppb negative, we might adjust it back to zero. But that's a very great point. And that's also where the importance of regular calibration comes in, because if you can regularly calibrate, you'll kind of avoid the situation where the sensor drifts. It might continually drift more and more negative, and you're going to be removing a greater proportion of the data over time, just because the sensor response signal is drifting more negative when you should be able to keep that data more if you were to keep it regularly calibrated. But that is great. That is a very great point, and that is a very great quality point to make sure that we don't also bias the data by, indiscriminately removing negative values.
I think Mike's comment is now on chat, so I'm going to come back here and read it. Mike says, with regards to the previous question, comparing sensors indoors versus outdoors, you should absolutely put all of your sensors in one place and make sure they respond similarly within some limit. If you put them inside, though, you will likely be getting a lower range of responses from the sensors due to less variance in concentrations, temperature, relative humidity, etc., as compared to the outdoors. Afri-Set's stance, and I think AQ Spec says similar things, question mark, is that you should co-locate, or in this case, just inspect sensor responses against each other in similar conditions to those where you will deploy the sensors.
Yeah, that's great. Yeah, and so what Mike was saying was largely consistent to my answer, which is when you're co-locating, you pretty much want to do it outdoors because of that range of pollutant concentrations that would be experienced. But on the more general point, yes, the best place to co-locate them is ultimately near where they will be deployed. So if you are doing an indoor kind of study, then perhaps an indoor co-location might be appropriate. But again, you're not really going to get that dynamic range of calibration points if you do an indoor kind of calibration. So thanks for that, Mike. I think Steve had one. Did you want to make one more comment?
So some of you have heard me say this before, but we put so much weight on these federal equivalency methods that are actually blessed by the government for a 24-hour time period. They actually carry no certification at a 1-hour time period. And that's largely because the federal, the true federal method is a gravimetric method. And in places like Europe and the United States where these methods are developed, you need 24 hours to get enough mass on the filter to weigh it. And at the standard flow rates, you won't have enough material on the filters to weigh it. I think there's a huge opportunity in African cities that have much higher levels than what we see in the US to test this assumption that we're all using when we look at hourly federal equivalency methods, whether they're good or not, by collecting some real gravimetric filters at standard flow rates with a good size selective inlet and comparing them to your reference grade monitor. And it'd be great to do that not just in one city, but to do it in cities with very different relative humidities and temperatures and sources. I think it would really help. So that's my soapbox comment.
I'm not opposed to it.
Hello. Thank you, Wilton, for that presentation. I have a question. Whose responsibility is it to carry out operation and preventive maintenance of sensors? Is it the users or the manufacturers?
Okay, whose responsibility is it to carry out maintenance of sensors?
To carry out operation and preventive maintenance of sensors.
I'm sorry, did you say operations and
Preventive.
preparative?
Preventive
Oh, preventive, okay.
maintenance of sensors. Is it the users or the manufacturers that should carry that out?
Uh-huh. Well, I think it's probably the user and or the people who are running the air monitoring project. I guess to me it doesn't matter either way, but I think a lot of manufacturers, they would be opposed to the idea that that it's their responsibility to make sure things are working correctly. To ensure data quality, I think they would prefer to, push that responsibility onto the user. Is that like a rhetorical question? Is this like a rhetorical question?
Because there are some activities that, there are some actions that the users cannot carry out on the sensors.
Uh-huh.
So I think some maintenance activities should be carried out by the manufacturers.
Okay.
But where to draw the line on what the manufacturers should do and what the users should do. That's what I'm trying to find out. Among some of those maintenance programs that you stated there.
I think it's probably. Man, I have to be so careful how I answer. I think it's probably reasonable to have users carry out, the replacement of consumables like cartridges that have a ending lifetime, or so.
I wanted to help out here. My suggestion would be that the nature of this question is the answer would. Sorry, I'm the one here. I'm trying to contribute an answer, and I think that if you buy your equipment, it's up to you to maintain it. Again, sometimes you have after-sales agreement. Some parts of it are so technical that if ordinary user goes in there, then the warranty is disrupted. And so within the lifespan that it was guaranteed, you take responsibility for doing something, and then the manufacturer stays out. So in terms of maintaining a sensor, you'll have to look at the conditions of use. If you have yours for years, it's like I have in my car. I wouldn't be asking the manufacturer to come and change the tire. But it's not like that in all equipment. So I think that who changes the sensor, who maintains the sensor is down to the organization and their relationship with the manufacturer.
Yeah, thank you. And I can at least agree that sensor manufacturers, they should design their products so that it is at least user serviceable. So sometimes these products are designed in a way that, like, if something breaks, you actually have no choice. You can't repair it yourself, or you can't replace a part yourself. You have to like throw it away, or you have to send it back to them to fix, or you have to have them replace it. So I think at a minimum, I would agree that it'd be good if the products were designed so that if a certain component failed, there's the option of you purchasing a replacement part to just swap it out yourself. That would be nice and ideal. But I don't know that I can take a position on like whose responsibility, like in philosophically, where does the line end at yours and mine's responsibility.
Okay. I have a question here. So, does environmental conditions, so my question is about the calibration, of sensors. So when you set them up, you have to calibrate them. And I get the idea that when you're calibrating them, you just have to do this co-location. So, for example, if you go to the center there, you have the sensors there, and then you have those that you want to calibrate co-located and taking measurements. Now the question is, does environmental conditions have impact on the performance of a sensor? If yes, why don't we factor like different environmental impact on sensor calibration?
Okay,
Do you get my question?
Yeah, I think the question was, do environmental conditions impact sensor performance, and why don't we account for those in the calibration?
Exactly. So if environmental conditions have an influence, then why don't we factor different environmental impact in sensor calibration?
Okay, that's a great question. So the first part of the question is yes, definitely. Environmental conditions do impact the performance of sensors. So for example, humidity is one of those conditions that kind of affects all kinds of sensors, whether it's an electrochemical cell or metal oxide, because the water vapor molecules will, occupy sites that then affect the resistivity or whatever of the gas sensor. And then for particle sensors, high humidity, that will contribute to particle growth. And so the particles will appear to be bigger than they really are when they're, when they go through the light scattering path. So yes, environmental factors do impact it. As far as incorporating those impacts into calibration functions, you can. So you don't necessarily have to do a simple linear regression. You could have a multiple linear regression calibration function that incorporates the, the influence of RH as one of the terms in that calibration function to account for that.